All right, on to one of my most favorite concepts, and that's the unit circle. So just a couple tidbits of information. You've been doing right triangle trigonometry, which should not be unfamiliar to you because you covered it in geometry. Now we're going to use that to derive the unit circle concepts. However, we're going to kind of push you away from that, especially when you're in radians and whatnot. It's just much easier if you get comfortable with this unit circle, especially for higher level math. You know, it's tedious to draw out triangles all of the time. So first you need to know a couple things about the unit circle. The unit circle is a circle with a radius of 1. Comes from this equation of a circle, and I don't know if you remember, and you won't have to know that, but that's the equation of a circle with a radius of 1. Each segment represents the terminal side of an angle. So when you have the unit circle, I'm just going to sketch a circle here. The radius is 1, okay, so this would be like 1 unit, you know, any radius is 1, so no matter where I go out there. And each segment represents the terminal side of an angle. So if this will actually, I can change colors here, but if this was my terminal side, my initial side and my terminal side, then you just know that you're going to find, you know, that measurement for your angle. The ordered pair at the end represents the point of intersection of the unit circle and the terminal ray. So this point right here, we're going to figure out how to get that point, something comma something. And the unit circle can be used to extend trig ratios beyond right triangles. And this is really most important because that's what you're going to be using it for. So before I dive into the nitty-gritty of the unit circle, I want you to understand where all this is coming from rather than me just telling you how it is. So I'm going to, here's an example of a unit circle. Okay, and you know that the radius is 1. I'll come back to that. And I just broke it down by, well, they should be familiar angles. So note here you have a 30-degree angle, a 45, and a 60. And you know all those special right triangles, the 30, 60, 90, 45, 45, 90, 60, 30, 90. And then I just kept going around and doing that again. So 120, if I turned it into a triangle here, you know, like connected here and made a triangle, this angle would be a 60-degree angle. If I take 135 and make a triangle with it, this angle would be 45. So you can kind of see that these are just complete reflections of the special right triangles that you know. So all of these are just reflections of 30s and 45s and 60 degrees. So you should, like, once you know these, you should be able to find all of this information quite easily. So I'm going to start with a 30-degree angle, and I'm actually going to remind you that the radius of a circle is 1, okay? And this is my 30-degree angle, so I'll just draw it all in blue here, and I'm going to just turn this into a right triangle. And I also know that this is 30, so I'm just going to get rid of theta there. So if this is 30 and that's 90, then this needs to be 60, nothing that you can't figure out. And then I know a 30, 60, 90 has the ratios of 1, 2, square root of 3. However, I know that my radius of my circle is 1, and this is my radius, so I'm going to put a 1 here, and that's my hypotenuse, which is supposed to be 2, so it's cut in half, right? So typically my hypotenuse is 2, now I'm cutting it in half to 1. So my other pieces I'm going to cut in half also. So my 30-degree opposite of it should be the 1, so I'm going to, oops, get my pen here. So that is typically 1, but I'm cutting everything in half because of my hypotenuse, so now it's 1/2. And then opposite of the 60-degree angle, you always know, is your square root of 3 measurement. However, I cut that in half also. So now, if I wanted to get to this terminal point here, where my terminal ray meets the circle, I would have to go, let me use my laser here, from the origin I would go to the right pi over 3 units and up 1/2 units, and that would be my coordinate point. So that, oops. So that point, I'm just going to fill in, is the square root of 3 over 2, comma, 1/2. Now, what you need to understand, of course, is that the order in which you went over, now you know that this length here is a cosine measure, And this length here is a sine measure, and I actually have that up here. So if I said, what is the cosine of theta? So in this case, what's the cosine of 30 degrees? You could just straight up tell me it's the square root of 3 over 2. Now at this point, you're like, yeah, I don't have that memorized, but eventually you'll get this memorized. Okay, now I'm going to go through the 45, 45, and I'm going to go through it a little bit quicker now that you kind of get the idea. So if I take this and turn it into a right triangle, I know that this is my 45-degree angle, this is 90, so this has to also be 45, and I know the ratio of a 45, 45, 90 is 1, 1 square root of 2. So my radius, however, is 1, and typically that's the square root of 2. So if it's supposed to be the square root of 2, but I have 1, obviously I'd have to divide by the square root of 2 to get that 1. So just mental note, I have to divide by the square root of 2. So if these were originally, these sides were originally 1, right? Well, now I'm going to have to divide by the square root of 2, so do a little math. You have to rationalize that denominator, so I'll multiply by the square root of 2 over 2, and I'll get the square root of 2 over 2. So that means these are now going to be square root of 2 over 2, instead of 1. So again, to get this terminal point, I would go over cosine units, up sine units. They're both the square root of 2 over 2, so that's nice and easy. So square root of 2 over 2, square root of 2 over 2. Now again, you might feel like, okay, there's no way I'm going to be able to derive this. Well, good news is you don't really have to always derive this stuff that I am deriving. It's like if you get these points, you kind of memorize them because you know how they come about. You don't always have to derive them. All right, last one I want to just make sure makes sense. I got the 60-degree angle, so again I'm going to turn it into a right triangle. I know that this is 60 degrees, which means this has to be 30. And of course I know 30, 60 again is the 1, 2, square root of 3 ratios. So my radius is 1, and it's supposed to be my hypotenuse again, which is supposed to be 2, so I'm just cutting everything in half. So that means I have to cut this in half and cut this in half, right? Because I cut this in half to get the 1. So that means opposite of my 60-degree angle, which is typically the square root of 3, now has to be the square root of 3 over 2. Opposite of my 30-degree angle, which is typically 1, now has to be 1/2. And again, to get this terminal point, I would go over cosine, up sine, so over 1/2, and up the square root of 3 over 2. All right, now that you get that, I'm going to go around and kind of fill in all of these points. So this was the square root of 3 over 2, 1/2. This was the square root of 2 over 2 and the square root of 2 over 2. And this was 1/2 and square root of 3. Now look at a couple patterns, of course. Note that the 30 and the 60 are just flipped, which totally makes sense because they're connected. I want you to think about these angles. So this, if you go over how many units? Well, if the radius is 1, you're going over 1 units, and then you're not moving up. So that means your cosine is 1, but your sine is 0. Now the rest of these, which are called quadrantal angles, should be really easy. Okay, so this one, I go over nothing, so it's 0, but I'm going up the radius length, so 1. This 180 degrees should be also very easy, so that's -1, 0, because I go to the left, and 270 is 0, -1. So those should be just kind of give-me's, and you can't get those from your triangles anyway. Now looking at this, 30-degree angle here is reflected over here, and here, and here. Okay, so all connected. So if I know this point, I know this point, and this point. How cool is that? Totally saving you some time. So here in your first quadrant, you know everything is positive. In your second quadrant, the cosine is negative, but the sine is positive because you're going to the left and up. In your third quadrant, you're going to the left and down, so they're both negative. In the fourth quadrant, you go positive to the right and then negative down. So basically, you're just changing signs on these 3 points. So over here, 120 and 60 match up, but I'm going to the left and up, so my 1/2 should negate. So that's going to be -1/2 and square root of 3 over 2. The 135 is a reflection of 40, so the, again, cosine is the only thing that changes, so it's a negative square root of 2 over 2, square root of 2 over 2. And then lastly, the 150 is negative square root of 3 over 2, and 1/2. Now, I challenge you, I have the completed one on Moodle, but I challenge you to finish these off. So these are going to be the same as these, but all negative, right? Because it's left and down. These are going to be the same as these, except for your sign value will be negative. So it should be very simple for you to get that. Okay, last but not least, I want to make sure you can get these radian measures, and you kind of get how radians work. So you know that the circumference of a circle is 2 pi, 2 pi r. So if circumference is 2 pi r, and you know the radius of this circle is 1, then the circumference is 2 pi. Well, if you know a full revolution of a circle is 360 degrees, then a full revolution in radians is 2 pi. Okay, so just kind of a reminder of where that comes from. So now I know that this is also 2 pi. Halfway around the circle would be 1 pi. A fourth of the way, if I take 2 pi and cut it into a fourth, would be pi over 4. And at 270 degrees, I'm going 3/4 the way around. So that would be 3 pi over 2. Now, as far as the rest of the, let's see if I can fix that, the rest of the unit circle goes, notice that your 30, your 30 and 60 degrees are splitting into 6. So I'm just going to make sure that this makes sense to you. Or actually, I'll start with the fourths. So the 45 degrees, in terms of pi anyway, it's splitting into 1/4, 2/4, 3/4, 4/4. And I'm just going to draw that in green so you can kind of follow. So again, this is, here would be 1/4, 2/4, 3/4, and 4/4, which of course is pi. So I know that this is 1/4. Let's see, where can I squeeze this in? I guess here, which is pi over 4. This is 2/4. Well, 2/4 is pi over 2. This one is 3/4, and then 4/4, which we know is pi. Then I'm going to keep going. That means this is 5/4 pi. Sorry. This is 6/4, which I've already got 3/2, and this is 7/4 pi, and then of course 8/4, which is 2 pi. And that gets me all my fourths. Again, super cool pattern. Now I got to get the rest of them, so that leaves me my 30s and 60s, right, all the way around. So then if I break these into 1, 2, 3, 4, 5, 6, that's going to take you all the way around. 7, 8, 9, 10, 11, 12. So now I'm going to break them into 6. So this, I'm probably going to make a huge mess, but again, this is on Moodle. So this is 1/6, so that would be pi over 6. This is 2/6, but reduce that, of course, so that's pi over 3. And this is 3/6, we got that. This is 4/6, which is 2/3 pi. This is 5/6 pi, and this is 6/6, and we got that pi. Then we got 7/6 pi, 8/6, whoops, I want to reduce that though, sorry, 8/6 pi, 9/6, which is 3/2, 10/6, let's see if I can squeeze that in there, 10/6, and 11/6, and 12/6, which is 2 pi. And now we have every degree and radian measure all the way around this unit circle. So you might ask, will I have to know anything not on this unit circle? And the answer is definitely not. So basically, you know this stuff. Now, at first, this might seem overwhelming, so you go through this and practice this on your own.